Next, let's look at starfishes and how they move. Before we look at how they move, let's look at their structure. So starfishes have endoskeleton. Their skeletons are inside their bodies, and they're made up of the structure we call as ossicle. Okay, ossicle is made up of calcium carbonate, which makes it stronger so that it can support the body of the starfish. Now, on this part of the starfish, we have something we call as sieve plate or madreporites. And the madreporites or sieve plates bring water into the body of the starfish. So the water around the starfish will move through the madreporite or the sieve plate, and then they will enter something we call as the radial canal. By the way, this is canal in Thai. Okay, is the function is just like a canal. So the madreporites bring the water inside, and the water will flow to the radial canal. From there, the water moves into these round structures, which we call as ampulla for one and ampullae for many. Now, the ampullae store the water. Okay, they store the water and they can push the water down into the tube feet. Okay, these are called tube feet or podium. Okay, you can see them moving. They are actually the feet of the starfish, and there can be hundreds of them or maybe even thousands of them. Okay, and they help the starfish to move. But let's look at how it works. Okay, how does it work? So first, we can see here the water moves into the body and they are stored in the ampullae. So from the sieve plate, it moves to the ampullae and they store. If the starfish wants to move, the ampullae will push the water into the tooth feet, which will make the tooth feet longer. And some muscles around the tooth feet will help to move it in the direction that the starfish wants to go. Again, so the water will move into the body from the sieve plate and goes to the canal. And when the starfish wants to move, the water which was stored in their ampullae or ampullae for many will push into the tooth feet. You can see here they're getting longer, and the muscles around the tooth feet will help to move the feet in the direction that the starfish wants. Next, let's look at squids and how they move. So first, the structure. So this is a structure of a squid on the ventral view. Ventral means it is what? On the lower side. We can see it has two fins, and it has this part we call as mantle. And it has eyes, it has tentacles, arms. But it also has this structure here, which looks like a little straw or a little tube we call as siphon or funnel. So how does the squid move? First, it pumps water under the mantle and into the body, and then it pumps the water out through the funnel or the siphon. It is just like the jet propulsion we saw in other organisms. So the jet will first push the water inside and then push it outside and helps it to move forward. It looks something like this. So the water goes in and then out through the siphon or the funnel. So if this straw is the siphon, the squid can change the direction of the siphon so that it can move in different directions like that. Sometimes to the back, sometimes forward. The last group of animals we will look at are insects. So first, the structure of insects. They have three parts: the head, the thorax, and the abdomen. And the wings are attached to the thorax. Now, insects move in two ways. Some insects move by direct movements, and some insects move by indirect movements. In direct movement, there are two muscles that are attached to the wings. Two muscles are attached to the wings. You can see them over here in different colors. Now, when they contract and relax, this will help their wings to move up and down, up and down. We call as upstroke and downstroke. Now, in direct movement, because the muscles are attached to the wings, each wing can be controlled independently. They can be controlled independently. Okay, this is independently in time. Example of insects that fly this way by direct movement are dragonflies and mayflies. Next, many insects fly by indirect movement. And in indirect movement, they have two muscles, but the two muscles are not attached. They are not directly joined to the wings. We can see the two muscles inside the thorax. And when the two muscles contract and relax, this will move the thorax up and down. And when the thorax moves up and down, it will move the wings up and down too. We have upstroke and downstroke. Now, here are some organisms or some insects that fly by indirect movement. Butterflies, houseflies, and many other insects, okay, fly using indirect movement. The muscles are not attached directly to the wings. Now, if you look at this table, it shows us how many beats per second that an insect can make. How many times can their wings beat in 1 second? We have housefly, we have about 190 beats per second. That is a lot. 1 second, it can beat 190 times. Dragonfly, about 38. Now, you might be thinking about mosquitoes because these guys are very annoying, okay? How many beats per second can they make? They're very hard to kill, right? If you try to kill them, they'll always run away. Mosquitoes can make a lot of beats per second. Sometimes even up to 1,000 beats per second. This is why it's so hard to kill, because it can easily fly away. So why can mosquitoes beat their wings so many times in 1 second? The answer is quite simple. Let's look at the answer here. Before a muscle can move, the nervous system has to send a nervous signal to the muscle, and the muscle can contract or relax to help to move the wings. In some muscles, when the signal goes to the muscle, it will contract and relax only one time for every signal. So one signal, one contraction and relaxation for one time. We call these the synchronous muscles. And in some muscles, when the signal is sent to the muscles, they can contract and relax many times for one signal. So mosquitoes have asynchronous muscles which help to contract and relax so many times per second. And this is why they are probably hard to kill, because their muscles can contract and relax many times per second. So we're going to stop here. This is the end. Thank you so much for watching, and I hope this is helpful.